Thank you for joining me on this adventure. Your presence means the world to me. Greetings, explorers of knowledge. Join us as we embark on a quest to understand Hadamard regularization. In mathematics, Hadamard regularization, also called Hadamard finite part or Hadamard's partie finie, is a method of regularizing divergent integrals by dropping some divergent terms and keeping the finite part, introduced by, showed that this can be interpreted as taking the meromorphic continuation of a convergent integral. In this section, we'll be exploring description. If the Cauchy principal value integral meromorphic obfract x quadritext for x subsists, then it may be differentiated with respect to obtain the Hadamard finite part integral as follows: abfract xi left markant abfract xitite markant obfract quadritext for x sub. Note that the symbols are used here to denote Cauchy principal value and Hadamard finite part integrals respectively. The Hadamard finite part integral above may also be given by the following equivalent definitions: a markant obfract lim of epsilon to left int x of epsilon fract int x of epsilon a bifract frac fax of epsilon a fax of epsilon right a markant obfract lim of epsilon to left int obfract if teaks of epsilon to frac fax of epsilon if frac fax left frac x frac x right. The definitions above may be derived by assuming that the function is differentiable infinitely many times at xb, that is, by assuming that can be represented by its Taylor series about x. For details, see. Note that the term in the second equivalent definition above is missing but this is corrected in the errata sheet of the book. Integral equations containing Hadamard finite part integrals with a known are termed hypersingular integral equations. Hypersingular integral equations arise in the formulation of many problems in mechanics, such as in fracture analysis. Now, we shift our focus to example a topic that deserves our attention. Consider the divergent integral int a fracat, left lim a to int e fracat, right a left limit to int a fracat, right lim a to left a frac a right limit to left one a frac a right. In fact, its Cauchy principal value also diverges since a markant a fracat lim of epsilon to left int of epsilon fracat int of epsilon fracat right lim of epsilon to left frac of epsilon 1 a frac of epsilon right equal. In fact, to assign a finite value to this divergent integral, we may consider a markant a fracat x big X a fract xi left markant a fracat x type big X. The inner Cauchy principal value is given by a markant a fracat x lim of epsilon to left int of epsilon fracat x int of epsilon fracat x type lim of epsilon to left on the frac epsilon x right on the frac epsilon right on the frac right. Therefore, a markant a fracat to fract xi left on the frac right big X a frac x a big X equal. Note that this value does not represent the area under the curve out, which is clearly always positive. However, it can be seen where this comes from. Recall the Cauchy principal value of this integral, when evaluated at the endpoints, took the form lim of epsilon to left frac of epsilon 1 a frac of epsilon right equal inf I. If one removes the infinite components, the pair of a frac of epsilon terms, that which remains is lim 2, which equals the value derived above. Have any questions or topics you'd like me to cover in future videos? Let me know in the comments.